notes. So just know we have one more section. Okay, geometric sequence. It's honestly kind of the same thing as what we learned in the previous chapter with arithmetic sequence. So it has its own formula. So here we have the explicit formula. A sub n is equal to a sub 1 parentheses r n minus 1. So a sub 1 is always the first term, and r just represents the common ratio. So for example, here we have an example of what an explicit formula looks like. This 2 is the very first term. This 3 is the common ratio. Oops. And then here's the graph for it. Now, this is the one that's mostly used a lot. The recursive formula isn't as much. So this is what the recursive formula looks like. A sub n is equal to the common ratio, parentheses, a sub n minus 1, parentheses. So she didn't put the instructions in the book. Try to see if you can find it online. Oh, here it is. There you go. Found it. All right, so let's do the first example. So state whether the following statement is true or false. Explain the sequence 2, 6, 18. Is it a geometric sequence? Yes or no? So looking at the pattern 2, 6, and 18, what is the pattern just by looking at my sequence? What is the pattern? Yes, not. Very, yes, by 3, yes. So my common ratio is equal to 3. Now, there's two ways to find the common ratio. It's kind of different than the other one. You can take the second term and divide it by the first term. So that's one way of finding the common ratio if you have a common sequence. Sometimes it's easy when it's all integers, but when you get to the fractions, it kind of makes it a little bit hard. So here's the cheat sheet to find the common ratio. It is the second term divided by the first term. So in this case, 6 divided by 3, which in this case, it is 2. So that is that's one way to find the common ratio. Now, in this case, is it true or false? The answer is true. Now, because we know that it's a common ratio between the whole thing. 2 times 3 is 6, 6 times 3 is 18. That means they're all the same. And it says because the common ratio of consecutive number sequence is constant is 3, it is true. So the answer is just A. It is not B because the constant is not 4. It is actually 3. So pretty easy, not too difficult concept what you're learning today. It's pretty straightforward. And a lot of it's just multiple choice. So anyone have any questions? Pretty easy. Oh, who it is. Determine whether the following sequence is geometric. If so, find the common ratio. So first, to find the common ratio, the second term divided by the first, which gives me 2. Now you gotta make sure it's the same all around. 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24. Very good. So it is common ratio. So that means I'm gonna write yes, it is geometric. And then the common ratio is just 2. Pretty easy, not too hard, not too difficult. Number 3, determine whether the following sequence is geometric. If so, find the common ratio. So this is where it can get a little bit confusing because you get to positive and negative. So all you have to do is just find the common ratio and just make sure it's the same for all the way going around. So in this case, the ratio is going to be from -2 divided by +1, which gives me -2. Now, is 1 times -2 -2? Yes. Is -2 times -2 +4? Yes. Is 4 times -2 -8? Yes. So if that's the case, this is in fact a geometric sequence, and the common ratio is -2. So don't get confused, don't get paranoid because of the negative. As long as it's true going through the whole sequence, it is considered a geometric sequence. So it is possible to have a positive negative sequence, but this is only true for geometric. Let's move on. Number 4. So you have two word problems. They're not too difficult. It says when a radioactive substance when a radioactive substance decays, measurements of the amount remaining over constant intervals of time form a geometric sequence. The table shows the amount of certain substance remaining after different constant intervals. Write the explicit and recursive formula for a geometric sequence formed by the amount of radioactive substance remaining. So the explicit formula for the geometric sequence formed by the amount of radioactive substance is A sub n. Yeah.
On paper, it says this is number 8.
I know there's a number 8 that looks exactly like number 4. So get the paper that has number 4 on it. Because number 4 and number 8 are exactly the same question, but they have different numbers. Okay, so in this case, to find the geometric sequence, so we're gonna write it down because it's right here. This is the explicit formula. So for the explicit formula, A sub n is equal to A sub 1, the ratio n minus 1. Now, luckily for us, A sub 1 is already given. It's the first term of our sequence, which is 240. So when we start, we have exactly 240 amount of picograms, and it's not 0. This is just the amount of time. So this is what the time starts at. Then it goes to 120, then 240, 360. So this is not the first term. It is actually 240. So do not get confused, especially when you get to the table. This is the starting amount. Now, to find the ratio, it is the second term divided by the first term. So in this case, it's 120 divided by 240. Now, what does 120 and 240 simplify to? Because you guys have to reduce it. Because if you write 120, 240, it's going to tell you it's wrong. Does anyone know what 20 or 240? What? How'd you get 1/2? Okay, good. Okay, here's another trick part that you can also do. Yes. Okay. So anytime you have a fraction and they both end on zeros, you can actually cancel them out because that means they're both divisible by 10. So you can actually cross out the zero. It's actually something I learned I can't remember if it was elementary school or middle school, but my teacher taught me if there's 2 zeros at the end, you just cross it out because they're divisible by 10. So now you have 12 or 24. And what does 12 and 24 simplify to? Now you can divide it by 2, but what other number can you divide it by? The bigger the number the faster you get this. Very good. So the bigger the number, the easier you'll have to reduce it by. So in this case, 12 divided by 12 is 1, and 24 divided by 12 is 2. So very good. So Shana got it correct. So it's 1/2. So now in order for me to write it in explicit formula, all I have to do is write 240 parentheses 1/2 and then to the power of n minus 1. This is the explicit formula. I don't have to write a sub n because it's already right there. So it's just this part. Does anyone have any questions? Now for the recursive formula, you always have to state the first term and then the formula. So the first term, which we already talked about, was 240. And then for the recursive formula, all we need is, I believe it was the ratio times a sub n minus 1. Yeah, it is a sub. So if this is just the ratio, parentheses a sub n minus 1. So we found out the ratio was 1/2, and then parentheses a sub n minus 1. You have to write that as a subscript. So make sure you click on the one that's on the bottom right. I think on Savas, I think it gives you like a square and then a little square. So that's the one that you want to use to put a subscript. So this is for Savas. So for when you do the formula, you have to click on the one that looks like a square, and then the one with the bottom right, and that's where you're gonna put the n minus 1. So when you do a recursive formula, and you're gonna get this on the test, when you write the recursive formula, you have to write the first term and then the formula afterwards. You gotta write both of these when you're writing the recursive formula. All right, any questions on number 4? All right, number 5. It says write the explicit formula for the geometric sequence. Now, for the explicit formula, a sub 1, which is our first term, which in this case is 6. Then we have to find the ratio. So we're going to take our second term, 30, divided by our first term, which is 6, which will give us 5. So that means the explicit formula is going to be a sub n 6 times 5 to the power of n minus 1, for n is greater than or equal to 1. So pretty easy, not too difficult. Yeah, we just had to put 6 and 5 inside the formula. For number 6, this is write a recursive formula for the explicit formula. For the explicit formula. Okay, so remember, for the explicit formula, we have a sub n equals a sub 1 parentheses r n minus 1, right? So the reason why I put it on top of it, because it turns out my first term is actually -3. My common ratio is 12. So that means a sub 1 is -3. And then to write it in the recursive formula, a sub n is equal to r parentheses a sub n minus 1, which in this case, 12 parentheses a sub n minus 1. And that is the recursive formula from the explicit formula. Does anyone have any questions so far? Now, if I asked you to write the first 4 numbers in my sequence, how would you write it? So it doesn't ask you for it, but it could be on the test. If your first number is -3 and your common ratio is 12, can you tell me what the first 3 numbers, not because the 4 is kind of gets too big. What are the 3 numbers in the sequence? What is the pattern of the sequence? Does anyone know? According to both of these formulas, what would the sequence look like? What? No, you wouldn't be adding 12. You're close. You're thinking of arithmetic. Okay, what number do I start with? What number do I start with? That's the important part. -3. Then what would the next one be? Not -9, not +12. What would the next number be? Very good. How did you get -36? There you go. You have to multiply everything by 12. So that means my first 3 would be -3, -36, and whatever 36 times 12 is kind of a big number. -432. So this is the sequence of my pattern according to the formula. So remember, you're multiplying by 12. All right, very good. So you guys are ready for your test for number 6. Number 7 says write a recursive formula for the explicit formula. So it's kind of the exact same thing. 13 is my first number, and then I'm going by every number I'm dividing by 4, or in this case, multiplying by 1/4. So a sub 1 is just 13, and then for my recursive formula, it is 1 divided by 4, parentheses, a sub n minus 1. And this is the recursive formula for my first term and my formula. Now just know a sub n, a is not capitalized, is lowercase. Number 8, it's the one in the back that looks exactly like the other one before. So it's just another practice. So it wants you to write the explicit formula according to the amount of radioactive substance remaining. So in this case, what is the first term in my sequence? Because I need it for my formula. What number am I starting with? 160. How do I find the common ratio? Which one is it? So you have a 50-50 chance of getting it right. Hold on. Is it 80 over 160 or is it 160 over 80? Hold on. I want her to answer it. Is that your final answer? Yes, that is correct. So it's 80 over 160. Okay, so now you have to reduce it because if you don't reduce it, the computer's gonna tell you it's wrong. So since we both end in zeros, we're gonna divide it by 10. So that means I'm left with 8 over 16. And what number can I reduce both of these by? Very good. These are both divisible by 8. So I should have 1/2 as my ratio. So that means my formula is going to be a sub n is equal to my first term, which is 160. Parentheses, my ratio, which in this case is 1/2, and then to the power of n minus 1. So remember to write a exponent, you're gonna click on the with the box, and then the box that's the top right hand corner. Because you have to put that's where you're gonna put the n minus 1. Now for the recursive formula, it's pretty straightforward. You only need the first term, which in this case is 160. And then for the formula, you just need the ratio, parentheses, a sub n minus 1. So this would look like 1/2, oops, no. 1/2, parentheses, a sub n minus 1. So now you have your two answers for the recursive and the explicit. And that is it. That is just today's lesson. So it's not too bad, not too difficult, but I definitely encourage you to write both of these formulas for your test on Thursday because you'll have one problem about explicit and recursive formula on your test, just like the other one too. So other than that, that's pretty much it. That is the end of today's lesson.